Okay, folks, Algebra 1, Section 8.20, and negative exponents. Guys, some of you we talked about this yesterday in class, and you asked some questions sort of related to this, and so we're going to get into it today with some zero and negative exponents. But the first thing I need to talk to you about is the division property, for us really to understand what's going on. I mean, I could tell you what to do with these things, but I want you to understand what's happening here. The division property, if you think about this, let's deal with x to the 6 divided by x to the 4th. Now you guys are going to remember that that's the same as x to the 6 over x to the 4th, because a division problem is a fraction. Okay? Now I'm going to write this out. X times x times x times x times x times x. Thanks, Mr. C. Yeah, 1, 2, 3, 4. Okay? But you know, if I've got exponents on the top and bottom, I can actually cancel these things. Those cancel, and that's just 1. That cancels, that cancels, that cancels. And what I'm left with is x squared. And we get this rule that since these cancel out, I'm always going to be left with 6 minus 4, or 2, on the top. See, the top had more than the bottom. How many more? 2 more. All I have to do is subtract to figure it out. 6 minus 4 gives me 2 left over. Okay, so that's the division property of exponents. We just subtract if two items have the same base, two powers have the same base, and we're dividing, we just subtract their exponents to satisfy it or to simplify it, and we get x squared. Okay, now that rule is going to apply in this next problem. If you look at the one below, and it says t to the 5th. This one right here. Whoa, I don't want that. Come on, Mr. C, get it together. All right, this problem right here. Okay, t to the 5th divided by t to the 5th. Now, the rule is still the same, right? So, if I subtract their exponents, that's going to be t to the 5 minus 5. That means I'm going to get t to the 0, but what does that mean? Well, let's do something that we did up at the top. Let's do t to the 5th over t to the 5th. Now that's true, right? Because it's a division problem. Wait a minute. Wait a minute. Any number over itself is always equal to 1. That means t to the 0, whatever it is, equals 1. T could be a billion, it could be -4, it could be the square root of 2, it could be any number raised to the 0 power gives me 1. There's only one number that doesn't work for. And I'm giving you a little time to think about it. I wonder which one it is. Wait a minute. It can't be 0. Because if t were 0, that means that it would be 0 over 0, and that we would have a 0 in the denominator. That would be bad. That's against the math law. No zeros in the denominator. That's undefined. Okay? So, the next rule is that any number raised to the 0 power always equals 1. Memorize it. You can do it. Okay, now, using the same ideas again. Okay, we did this problem up here. Just going to draw a box around it. That was one problem. Now we've done this problem right here. And the next problem we're going to do is this m to the 3rd divided by m to the 6th. Now, guys, the rule's the same. I just subtract their exponents. That's going to be m to the 3 minus 6, and that's going to give me m to the -3. But I'm going to write below it here m cubed over m to the 6. That's the same thing because it's a division problem. All right, well, let's figure out what that equals then. It's going to be m times m times m over m with multiplications between them. This one cancels, this one cancels, this one's cancel. And I'm left, oh, Mr. C, I'm left with 0 over m cubed. No, you're not left with 0. What's on top? 1 over m cubed. Now, what does that mean? That means that m to the -3 is equal to 1 over m cubed. So, what that means is, the rule is, this negative exponent means it's on the wrong side of the fraction bar. All right, I'm going to extend this page a little bit, and I want to say that m to the -3 is equal to